Welcome to Google Cloud Next on Air. In this session, I'll cover what's new with Cloud SQL. My name is Brett Hesterberg, and I'm a product manager on Cloud SQL. Even though we can't meet in person today, I'm hopeful that we can learn a little bit about each other. Using your question pane or your comment pane on your screen, if you feel comfortable, please comment in your job title. Are you a database administrator, a reluctant database administrator, maybe a DevOps engineer or developer, or something else? Also, please chat in your preferred or the relational database that you work on most often. Maybe it's MySQL, SQL Server, uh, Postgres, Oracle, Sybase, DB2, or something else. We'd love to know what you're working on day to day. Also, as part of Google Cloud Next expert sessions, I'm available to meet one-on-one and talk more about Cloud SQL. I encourage you to reach out. Today, we're going to talk about four major areas. One is how we can find more flexibility in your database environment, how we can protect against the unexpected, gain automatic transparency and trusted security controls, and lastly, we'll round out with ways to easily stay up to date without the risk. Before we jump into these topics, let's start with a quick look at Cloud SQL. Cloud SQL is a managed database service that offers MySQL, SQL Server, and PostgreSQL. This means that if you have an application that uses MySQL, SQL Server, or PostgreSQL, it will work with Cloud SQL. Cloud SQL focuses on managing mundane administration aspects of these databases, and I'll talk about that a little bit more. Beyond just application compatibility, it means that Cloud SQL is compatible with your favorite database administration tools. So if you're a SQL Server user, for example, I encourage you to take a look at the links on this slide. Here, we're talking about how SQL Server users can use their favorite administration tool with Cloud SQL, incorporating the Cloud SQL proxy, which makes Cloud SQL instances in the cloud look local to any machine that you're working on. Follow up on those links if you're interested in learning more. When I think about running a database, this tends to be the technology stack or the diagram of a stack that I think of. At the leftmost column, we see things related to running a data center or a server environment in general. This means server maintenance, racking and stacking, power, HVAC, and networking, things that go into a data center or any server environment. Of course, this is taken care of for you in the cloud, where with Cloud SQL, when we offer an instance and you configure the number of eCPU cores or RAM, we make sure that you get a consistent experience, that number of cores and RAM, even as our underlying hardware changes. Moving one column to the right, we look at the operating system, both installation and patching or keeping the operating system up to date. One more column to the right is finally the database. Here we're installing the database, we're keeping it up to date with its own set of patches, and we're starting to protect data with scheduled backups. And then rightmost in the diagram are things like high availability, which usually includes some health checking and maybe automatic failover, as well as scalability, where we're using often replication to scale out reads to replicas. We want to wrap this whole technology stack in monitoring so that if there is a problem, we're able to quickly find the root cause. Cloud SQL's job is to take this stack or this diagram that you see, what it really takes to run a database, and wrap all of that in an API, CLI, and UI so that for your application teams in your environment or your developers, they can easily start up and create a dev or test database, which might be very simple, but just as easily create a production grade database, which means it includes high availability, which relies on synchronous replication and automatic failover, includes a backup plan for data protection, and even cross-region replication for disaster recovery. Again, all of these wrapped in an API, CLI, or UI that means in just a few minutes you can get this set up. Tim sums this up well, and Tim Kelton is a customer at Descartes Labs. He says Cloud SQL gives his team a bit more time to work on the products that provide value to his customers. His team has decided they're going to spend less time on certain aspects of database administration, turn those over to Cloud SQL so they can focus their time elsewhere on products that are more valuable to their customers. I think Tim sums that up well. And one thing to note here is that the diagram I showed and what's also backing Tim's quote is a dedicated SRE team, Site Reliability Engineering team for Cloud SQL that is on call 24/7. These are the folks who write the automation to make sure our service is healthy and runs well. And when automation fails, they're also the folks who can put hands on keyboard to get a database back up and running. Now that we've taken a look at Cloud SQL, we'll start to introduce what's new. What have we been up to in the past few months? And I think what you'll find is we have great momentum in terms of enterprise features. We're building on an enterprise feature set with a number of these new features that we'll cover today. First, let's find some flexibility in your database environment. We'll start with BigQuery to Cloud SQL Federation. This enhancement gives analysts a way to quickly reduce time to value for business insight. Perhaps they want to explore some data without setting up a pipeline first, or perhaps they have a quick question they need to answer, and that data might be spread across multiple Cloud SQL instances and even other data sources. With BigQuery to Cloud SQL Federation, the analyst can query one or more Cloud SQL instances and join that data with data that already resides in BigQuery, or perhaps resides in one of the other external data sources supported by BigQuery. What you see in the slide is a depiction of a very simple query an analyst is running in BigQuery where they're using the external query function, which is what we use to ask Cloud SQL to go run a query. Here, the query set to Cloud SQL has been input by the analyst, which means we're pushing down the query or asking Cloud SQL to run the aggregates, for example, so that we're not sending back blindly a large table of data. The data sent back from Cloud SQL is in table format and can then be joined with other Cloud SQL data, other BQ data, or data from another external source supported by BigQuery. All of this can be done without setting up a pipeline. And once an analyst is sure that the insights being provided are useful, from there, the team can decide to build pipelines or a regular reporting schedule. Next, we'll look at committed use discounts. And we don't often think of pricing and flexibility in the same sentence. Hopefully, what you'll find is that what we've done with committed use discounts is indeed flexible. A committed use discount is ideal for a workload with predictable resource needs. This is a way of saying that they're great for environments where you're running a number of Cloud SQL instances 24/7. You know that each month you're going to spend a certain amount on Cloud SQL. When you commit to a 1-year or a 3-year term with a committed use discount, or a CUD as they'll call them, you receive either a 25% or a 52% discount 1 year and 3 year. The flexibility comes in with committed use discounts in that these are easily and fully transferable between the database engines supported by Cloud SQL, MySQL, PostgreSQL, as well as SQL Server. The committed use discounts, or CUDs, discount against the vCPUs, or CPU cores, and RAM associated with each of your Cloud SQL instances. And here, if your database estate changes, let's say from SQL Server to Postgres over time, it's no problem. Your CUDs will continue to apply, and you don't even need to reach out to us. Not only are these fully transferable, but you don't need to take any specific action. You purchase a committed use discount in a currency denomination, for example, dollars, and we charge your instance rates against that commitment each month. These are also fully transferable between machine sizes. So you don't need to forecast which machine size or how many CPUs per machine you'll be needing in the future. You simply use CPUs as you see fit. They'll count against your committed use discount. In this way, your database estate can change quite dramatically over, say, a 3-year period of time without any problems applying to committed use discounts. We hope this will make your planning for committed use discounts much easier with a lot less forecasting, and that you find the whole process to be indeed flexible. Looking now at how to protect against the unexpected, we'll start with disaster recovery. In Google Cloud terms, we often categorize disasters as a region outage. A region in Google Cloud is comprised of 3 or more zones, where a zone is a separate failure domain. This means that if we have a problem in Zone A, it usually doesn't affect Zone B or Zone C, so a guard in itself against a regional outage. But if a regional outage were to occur where 2 or more of the zones in a region are down, we have introduced a cross-region replica enhancement, or cross-region replication enhancement, that allows you to guard against this sort of outage, a full region outage. With a cross-region replica, you're able to ensure that you have a near real-time copy of your data in any region around the world, other than in your primary region. We're using Google's global network, as well as Google Cloud's VPCs, which are global in nature, spanning all regions in the world, to ensure that this experience is easy to set up and it can be made very secure and private via our VPC option. So what you see in this slide, in the screenshot, is that I'm selecting a region something other than where I have my primary instance. So if my primary instance is in, for example, US Central 1, here I'm selecting US West 1 as my region for the replica. And that's really about all I have to do. This will now take advantage of my private VPC network, so I know I'm securely transferring data, or copying data rather, in near real time to my replica. And the replica is now available in another region than my primary instance. This means in the event that I have a outage in my primary region, US Central 1, I know I have a near real-time data set that can be made available very quickly in another region in case of that disaster. Of note here is that this replica is also a standard replica, meaning if you have users in another region who need low latency reads to a replica, or you want to run reporting, for example, on the replica, you can certainly do so, knowing that the replica is still available for disaster recovery purposes. We talk a lot about disasters and widespread outages. You all have done a lot of disaster planning as part of your careers in IT. What we tend to realize, though, is often the more common event is a user error. We are sort of the disaster, if you will. I might drop a table or change row data by mistake, and I want an undo button to get back in time before I change that data so I can get back to where I was. We've long had point-in-time recovery for our MySQL product in Cloud SQL. We're now proud to introduce it for PostgreSQL as well. With PostgreSQL, we store transaction logs, or WALs, for the past 7 days, which allow you as a user to select a millisecond at any point in the last 7 days. So if I made a mistake on a Friday afternoon, for example, and I don't realize it until Monday morning, it's easy for me to get back to the millisecond or the second before I made that mistake on Friday and recover that data. It gives me an undo button, as I mentioned, and it helps to protect against the more common issue, which is user error. These features add to Cloud SQL's enterprise-ready list for data protection and disaster recovery. And I think it's worth summarizing how to build a production instance with Cloud SQL. You start by enabling automatic daily backups, and I'd encourage you to consider taking more frequent on-demand backups, especially when you're making a major change to your database. For example, you might be making a schema change. It's a great time to take an on-demand backup just before you make that change in case anything goes wrong. I'd encourage you also to enable point-in-time recovery so that you have very granular restore options for the last 7 days, as the example was with PostgreSQL. You can get back now to any millisecond in time in case of a user error. We also have an export mechanism in Cloud SQL that allows you to export your data in a portable format to Google Cloud Storage, or GCS. This can be a multi-region bucket, a single region bucket, or otherwise. When you use multi-region buckets, it ensures that in a regional outage, your data is automatically replicated and stored in another region so you can gain access to it. You can also store these exports in any other object storage, meaning on premises or in another cloud provider. It allows you a very portable format of your data so that you can take it where you want. In region, ensure that you enable high availability. High availability tells Cloud SQL, the high availability configuration, tells Cloud SQL to do automatic health checking of your instance and to set up synchronous replication between zones so that in the event of a problem, we automatically fail over on your behalf, bringing your database back up even after a major fault. This is necessary for the SLA and generally good availability guidance for any production system. Lastly, as I mentioned, to protect against a region outage, consider using our cross-region replication or cross-region replicas. Again, you'll have a near real-time copy, asynchronous replication, which means you'll have data available to you in another region should your primary region have an outage, and you can make that data accessible very quickly to applications to get back online. Looking now at how to get automatic transparency and trusted security controls, we'll start with access transparency. Access transparency gives you near real-time logs when a Google Cloud administrator accesses your content. Cloud audit logs already provide visibility into the actions of your own administrators. So for example, your administrators might be creating a Cloud SQL instance, taking a few backups via our API. All of this is logged today. However, this audit trail typically or previously stopped once your cloud provider support or engineering team is engaged. We previously didn't log those transactions. Now, when you open a support ticket with our support team via access transparency, you'll see their actions in your audit log as well for our manual and targeted accesses, again, either by support or engineering to get your database back online. You can take this further with access approval. So beyond just logging and viewing the access, you can use the access approval feature to increase your level of control by requiring explicit approvals before Google support or engineering can access your data or configurations on Google Cloud. I recommend taking a look at both access transparency and access approval to see how they fit with your environment. Next up, let's look at encryption, and specifically customer-managed encryption keys. These keys are intended for organizations that have sensitive or regulated data that requires them to manage their own encryption key. These keys are stored in a key management system that you manage. We're using keys in Cloud SQL that you manage, and we access them as part of our operations. Should you remove access from that key, then when Cloud SQL performs a major operation next, it won't be able to get the key, and access to that system is shut down. Again, this feature allows you to use cryptographic keys that you manage to control your data at rest, the data we store in Cloud SQL. I mentioned earlier Google Cloud's global VPCs. We've introduced in Cloud SQL support for VPC service controls. These generally in GCP allow you to define very fine-grained perimeter controls across numerous Google Cloud services, of course, including Cloud SQL. For Cloud SQL, this pairs very well with VPCs or private IP addresses. With the combination of private IP addresses and VPC service controls, you're now able to make private your Cloud SQL instances both from a data path perspective as well as a control path perspective. The private IP or VPC allows you to protect the data path, the things that your clients and applications are connecting to, by using a private IP address on a VPC that you control. VPC service controls for Cloud SQL protect the administrative API, who can create Cloud SQL instances, who can take backups via the API or the UI, for example. You're now able to make our administration API totally private as well, ensuring that you can control where your teams can access Cloud SQL instances, not just on the data path, but also on the control path of the admin API. Let's round it out with how to stay up to date without the risk. As a reminder, Cloud SQL has long offered maintenance windows, which are 1 hour per week times when you define that Google can perform maintenance on your instance. In general, Cloud SQL typically performs maintenance once a quarter on your instances to apply patches and keep things up to date. We would adhere to your maintenance window as you see in this diagram. One thing to note about maintenance windows is that we offer certain timings. If in a given project you have dev and test database instances, as well as some production database instances, you might put the dev and test databases on the earlier timing, and you might put the production databases on the later timing. This ensures then that the dev test instances on the earlier timing get maintenance or receive maintenance about a week in advance of your production instances. That way it gives you a chance to test the updates with your application before they go into your production environment. We've recently added maintenance notification and rescheduling. When you opt in, we'll email you a week in advance of maintenance, letting you know that we're planning to perform maintenance in your next maintenance window. You get a few options as part of this notification, including the ability to reschedule to a following window 1 week later, or the ability to apply maintenance anytime you click the Apply Now button. You can also set a specific time, anytime in the next 2 weeks, to apply maintenance if you're not happy with your current maintenance window schedule. This gives you much more control as to when maintenance is applied, especially on your production instances, and lets your teams know well in advance that maintenance will be performed. To wrap up, hopefully these features help you find a bit more flexibility in your environment with things like BigQuery federation and committed use discounts, help you protect against the unexpected, be that user error with point-in-time recovery or a regional outage with cross-region replication and disaster recovery. They'll allow you to get automatic transparency and trusted security controls, things like private IP and now the addition of VPC security controls, for example, as well as customer-managed encryption keys. And we'll round it out with our new maintenance notifications and rescheduling functionality. As you can see, Cloud SQL is continuing to build its momentum with respect to enterprise features, and you can expect to see more of this in future offerings. For next steps, I encourage you to take a look at 2 other sessions. The first, a data monetization story, where McKesson talks about their journey to Google Cloud. And please take a look at the bare metal solution, which will help you bring your enterprise workloads to GCP. If you want to see Cloud SQL in action, take a look at our showcase demo, which is a whack-a-mole style high availability demonstration. I mentioned high availability briefly. In this demonstration, as I mentioned, whack-a-mole style, you'll get to see how many Cloud SQL instances can you make fail and how many recover in the amount of time you're given in the game. Take a look. Lastly, get hands-on with Cloud SQL and try it out with our Quick Labs quest. In the quest, you'll be introduced to Cloud SQL from beginner knowledge all the way through advanced, touching on a lot of the features that I've talked about today. By the end, I think you'll feel very comfortable using Cloud SQL, and you'll hopefully be taking advantage of some of the enhancements that we've brought out this year. Thank you all for spending this time with me and watching the session. As I mentioned, I'll be available as part of our Google Cloud Next expert sessions if you want to meet one-on-one and talk a little more about Cloud SQL. Thank you again.